Alright, so you've done the experiment where you've measured the absorbance of your protein samples and you want to graph that relationship between the amount of protein and the absorbance in the spectrophotometer. Then, with that information, we can then figure out what our unknown samples are. But first things first, you gotta make the graph. How I like to do it is go up to scatter and get the mark scattered. That gives you this blank graphing area. I like doing it this way, go to select data, because I get to control what goes on what axis rather than letting Excel decide for me. So our x values should be our independent variable, which is the different amounts of protein. So you want to select those. Come back here, and then your y values, your dependent variable, you should be your absorbance, so you select those guys. Get that, and click OK. Now you got your graph. That's not too bad, but a graph without labels is, something that you're not going to get a grade on. So one easy way to start putting your labels on is come up here to Quick Layouts, and the first one, you click on it, gives you all this good stuff. And so I can come here, you click on where it says Axis Title, Axis Title, and you type in micrograms of protein, or whatever it is that you have on that axis. And then over here you do the same thing, but over here you type in the absorbance and the chart title. We're going to make standard curve, micrograms versus absorbance, or something similar like that. Okay. Now the next thing we need to do is put the trend line on here, because it's really that trend line that shows the relationship between these two items, and it'll allow us to calculate our unknowns. And there's definitely a couple different ways to get your trend line, but one pretty easy one is to click on your graph, so it's selected. That's where you get this little circle around it. And you can see you get a few more menus, and you go to chart layout. Chart layout's actually one of the best little sub-menus, because pretty much anything you want to adjust or make pretty, you do it here. Go to the trend line button, and I like to go to trend line options because there's things we need to do to make this worthwhile, and we might as well do it in one trip. So trend line options, we want a linear one in this case because basically our data makes a nice straight line. See, nice straight line, and that's what a linear one is. So we'll collect that and then go to options, and we want display equation and display r squared. Click OK, and you can see now we have an equation on our graph that follows the form of y equals mx plus b. So it's just a nice little thing you should remember from algebra class. But this thing is the key, because this allows us to find the value of any amount or any value of the absorbance along this line. So let's say we had an absorbance of 0.4. You're basically following that out to where you hit our line, our trend line, and come down, and we know an absorbance of 0.4 should have about 4 micrograms. And if you look over our data, that's the relationship we're seeing. But our unknown here, it's got a value of 0.15, which, it's somewhere in here, it's going to be somewhere in there. We'll have, somewhere between 0 and 2 micrograms. But what exactly is this number? And that's where we use this equation for. Alright, so what we have to do with this equation is put our value into it. But, is 0.15 the y or the x? Well, if you recall, we put our absorbance values on the y-axis, so this is actually a value of y. So if we were to, type this out or work on this, we'd have 0.15 equals 0.0995x plus 0.0041. But Excel can't really do anything with that. It's just just to show you guys what it looks like. Now, if we rearrange this and solve for x, again, algebra coming back to haunt you. Hopefully not. You can have Excel do these calculations for you. So if we click over here, we're going to do equals. Now, what do we do with when you're solving algebraically? We'll have the 0.15. Better yet, instead of 0.15, you click on the cell where our data is. That way, if anything changes, we can use it. and you bring the one component over by subtracting it from both sides, so we get a minus 0.0041, and then we divide by 0.0995, and that should get us it. So that's basically saying that at an absorbance of 0.15 we have 1.466 micrograms or thereabouts. So does that make sense? Well, 0.15, we come up to our original data, it's somewhere between 1 and 2 micrograms, so yeah, it looks pretty good. Now here's the other bonus about doing it this way. Let's say we had done a whole bunch of data and it's all typed in here for us, and we just programmed this equation and you drag it down, and now Excel has done all that for us. So by solving the algebraic equation once and typing in a way that Excel understands, you can use it to do lots of calculations for you, and that's really the plan. Now you'll notice our unknowns in no shape or form end up on this graph, which always seems to be a common mistake students make. So try to avoid that, and hopefully this will be helpful as you do a bunch of these during this class.